Good morning, how are you doing? I didn't say good morning because it is quite early here today. Hi, I'm Tom, I talk about code. Today, we're going to be doing some exciting stuff. We're going to be getting back into PlayStation 2 hardware. I'm still going to be working on the 2D game. At some point, I've got some things I want to do with Collision, but this stream we're going to focus in, we're going to tackle a real technical problem on the PlayStation 2. Hi, Anakim Luke, great to see you. 8 p.m. here. Yeah, I've been meaning to do some more early streams because all the people in cool time zones who tune into me seem to be living in America or Brazil. I don't know why. I get a lot of Brazilian viewers on my YouTube videos. So if you're from Brazil, big shout out. I wish I could say that in Spanish. Okay, so I have been busy. I have been setting things up a little bit nicer behind the scenes. So we now have a project which I'll be linking around in my YouTube videos from now on. You can track the things that I'm working on in PlayStation 2 Homebrew. Some of this may be off camera. Oh, you're Brazilian. Awesome. That I just assumed you were American for some reason, but yeah, that checks out. That checks out. Why is the PlayStation 2 so popular in Brazil? Is it just because it's like, you know, a huge, like, so many of them were produced and they're really, really cheap, or yeah, whatever. But so I've been trying to track things that I've been working on, right? I think I showed this just the other day where I'm having some texture issues on hardware, and this has been good. We had a little bit of discussion with one of the PCSX2 devs who ran my tests and noticed some interesting stuff, but still no resolution of that, unfortunately. Today, we're going to be picking up this story called Gift Transfers using DMA Source Chains. So, there's a lot of terminology to get into here, I guess. This is a very dense title. Let's start with some goals, okay? And I want to start getting the habit of writing out some goals for my streams at the start because my last stream felt a little bit chaotic, so goals. DMA source chain transfers. I've actually handwritten some notes about what I need to achieve here, right? Or I guess some of the technical details that I need to get in. The problem we're solving is that image uploads are really, really inefficient because we have to load an image into RAM, and then we have to copy that image into another buffer in RAM, and then we upload it. I write super well with the mouse. Thank you very much. It's all the hardcore arena FPS aiming, right? I've got really good mouse control. So, goal number one. We need to take what we're already doing and we just want to shove one little bit of information at the start and one little bit of information at the end and change the DMA mode we're using when we send information from the CPU to the graphics synthesizer, okay? So that's going to be probably a 2-line of code change, but there may be some nuance that makes it a little bit harder. So goal one, send... Oh, you've said my handwriting looked good, so get ready for it to get worse. I'm self-conscious of it now. Send DMA to GIF as chain. Yeah. So that's a pretty good description without getting into all the DMA terminology, which I will do. I have another blank canvas where I'll like draw some pictures of what this will look like in memory. Goal number 2 is going to be to, I guess, chain multiple DMA packets together, right? Multiple DMA packets. And I guess the sub-goal of this will be, what's the image reference? Okay, so what does this mean? What does this mean? And then I guess there's kind of like a... Well, no, yeah, let's start there. Let's start there. That will probably take me an entire stream because things will go wrong. So at the moment, when we submit something, how many lines of code do I expect to have removed by the end of the day? Or added. So I'm gonna be prototyping all of this in Lua. I guess, hold on. So let's make a note of that as well. So Lua. But if this works, I want to start maybe doing things in C and porting my Draw2D API over to C so that it runs faster. This is one of my issues in our backlog here. This is in my to-do column, rather. Apparently I haven't put it in there. Where is it? Oh, no, it isn't. Okay, well, I need to make an issue for that. But yeah, like the way I'm doing things in Lua is nice. It's been good to prototype, but it's really slow. Last stream we showed that when I was trying to draw a tile map, once I hit like a 10 by 10 grid of tiles that was completely filled in, my FPS went to like nothing. It was really, really bad. So yeah, we'll be getting into C. Anakin Luke asks, how do I memorize the syntax for function pointers? You don't. It's impossible. You just go to Stack Overflow every single time. That's what I do. So let's talk about memory, okay? At the moment, we send buffers off to the graphics synthesizer. So we have a buffer in memory, right? We fill it with a bunch of data about setting registers, and that gets sent off to GIF, which then kind of sends it off to GS. This is how you move things into the rasterizer of the PlayStation 2, kind of the GPU. And we do this with what's called a DMA normal transfer. And so what this does is just takes the buffer and sends it off, right? So we're going to move into using what's called a DMA chain transfer. And so in a DMA chain transfer, we have still a buffer in memory, but the first bit of the buffer, it's going to be what's called a DMA tag. And that DMA tag is going to tell us that we have a bunch of stuff down here. And then we might have another DMA tag that has a bunch of stuff down here. And then eventually we'll have something that tells it that the DMA tag is over. And so this is a DMA chain, because we're linking a bunch of things together, right? Awesome. It's not quite this simple though. There are a couple of different tags, and it means we can actually have different layouts in memory. So in a simplistic way, we can call this a DMA chain, right? And this will still get sent off to GIF, and that'll send it off to GS, and then these will be interpreted as commands that actually draw things on the screen. So as a starting point, we can think about it like this, and we can imagine that we just take our existing buffer, we add a DMA tag at the start, and we add a DMA end tag at the end, and then we just change the mode. It'll be just changing one function from DMA normal to DMA chain. Perfect. Whoop. That wasn't what I wanted. The complication comes in that there are a bunch of different types of DMA tags that do different things. So this kind of DMA tag where you say, here's a tag, there's a bunch of data following this tag that we're going to send, and then the next tag follows that data. This is called a continuation. CNT, continuation. There's also a type of DMA tag called a ref, and we're basically just going to use CNT and ref. There's also next. So let's change this drawing a little. Let's change this drawing a little. Oh no, I didn't draw this on a new layer. Let's not change this drawing a little. So how do I show a ref? So with a ref, instead of having all of our data in the buffer, we would just have a list of DMA tags, right? We would say DMA tag, DMA tag, DMA tag, DMA tag, and these tags would reference other buffers. So for example, if we want to upload images into the graphics synthesizer, this is a great way to do it. We have our images loaded into memory rather than what we're doing now, which is copying them all into one big buffer. So we have it in memory and then we copy it into a different place in memory so we can send it off. Now we can just reference buffers arbitrarily. And so the way a ref works is you give it an address, the DMA tag, when you initialize the DMA, it transfers whatever this tag references, and then it jumps to the position after the tag, the quad word after the tag, and that is the next tag we do. So if this is a ref, it'll then reference more data and more data. You can mix and match these though. So we could have a bunch of drawing commands and then reference a texture to upload and then have a bunch more drawing commands. You can mix and match. There's also a third type which is interesting, which I think we maybe won't use quite as much, but it does seem really interesting as well. And I think in a perfect world with really efficient rendering, you would use this quite a bit. This is where it's going to look quite similar to a continuation. You have a DMA tag and then a bunch of information, but the next tag you jump to is referenced. So once you've transferred this, it points to another DMA tag. So I guess for simplicity, yeah, let's say that it's another next, right? So you have a DMA tag, then you have more data, and then you jump again to another buffer, right? Etc. So we have a continuation, we have a ref, and we have next. So in all these examples, right, this is a continuation and a continuation and a continuation, blah, blah, blah. This is a ref and a ref and a ref. This is a next and a next and a next. You can mix and match. So let's think about what our draw example will actually look like, right? Just start dereferencing until things start to work. I love a good memory reference, right? So there are actually two more, so ref has two variants. One is called ref E, which is a ref, but it's the last thing you do in a DMA chain. There's also ref S, which is to do with how things get like blocking and slicing together of when you have multiple DMAs on the go. I can't remember what the S stands for. It might stand for sequencing or something. But so let's imagine that we're drawing. So we start our buffer. We start our draw buffer, okay? And we put a DMA tag at the top and we say, hey, here are some drawing commands. And they go here. And then we realize that we need our texture, right? We try and draw a sprite. We know that the texture isn't in VRAM. So we put a DMA tag that says, okay, we're going to upload... Well, we put a DMA tag that says, okay, we need to set up some registers for the uploading of a texture. And then we put another DMA tag that says, okay, we're now referencing... Let's make that a little bit bigger. We're now referencing a texture somewhere else in memory. And then we have another DMA tag. And that's going to be another continuation for actually drawing a sprite. Sign up Sido. You're new with PS2SDK. Can you make a video about how to set up and install the SDK? I get asked this a lot, okay? I have never had a problem setting up PS2SDK. I've always done it on Linux. I've always just run the scripts in PS2 dev. These scripts always worked for me. So I don't really know what I would say in a video other than go to this page and just do what these things say. I see people have problems with them. People ask on the PS2 scene Discord, and that's probably the best place to come with questions if you're having problems. But yeah, unfortunately, I don't have much to add. The thing that I keep telling people is, I build this stuff in the Docker image. So I don't actually have PS2SDK installed on my machine. I use the Docker image that is also built in this repo. It just makes my life a little bit easier. You know, it makes it easy to update and stuff, or to lock myself into a certain version. I actually use a slightly modified version. So from the PS2 dev image, I just pull in a few extra utilities, like one for building ISOs for packaging. The Docker file doesn't have make by default, so I have to add it in. Stuff like wget patch is a useful utility, bash, so that we have a slightly nicer shell environment. So, you know, if you want to work with the Docker file, which if you're not familiar with, I highly recommend, the Docker file I use is in this repository where all of my homebrew core engine code lives. That is my advice. Okay, so this was not as clear as I had hoped, but this is actually a roadmap we can work from. And the first thing to do is to just try and add this continuation tag at the start and this kind of end tag at the end of what we're already doing, change from a DMA normal to a DMA chain, and then hope that it works. So I think I already made the branch. Yeah, perfect. Let's go into our source. Let's go into dmalua.c. We need to add... So at the moment, we're using this DMA send buffer function, and this is okay. We probably need to... Well, this name is a bit too overloaded, right? It doesn't really actually have the nuance for what we need. So we need to rename this to send normal. And then we're also going to add another function. Source chain. Another important detail I missed here, sorry. So source chain versus destination chain. There are two types of chain. The source chain means that the way we're linking these things together, the thing that changes is where we're sending data from, right? When we have a reference, we're referencing buffers in other places of our memory, but so the sender has data scattered all around, but it gets consolidated into one nice list in the receiver. A destination chain is kind of the opposite. We have one nice list, but we can send it to lots of different places in the destination. So, Anakin, Luke, you absolutely can ask a question. Interrupt me anytime, please. And yeah, if you have questions, other people almost certainly have the same questions, so please ask away. Oh boy. Promise I won't rage quit. No. Okay, hold on. What is this question? What's DMA? Awesome. No, holy crap. I completely shot over this. This is an awesome question. Thank you very much. So, DMA stands for Direct Memory Access. DMA is how we send information from one part of the PlayStation 2 to another. So, everything we're talking about here, we're sending buffers from main memory to a hardware component called the GIF. And the cool thing about DMA is, rather than like having a loop in the CPU where we say, write to some magic memory address that sends it across, we don't have to manage it in the CPU. We initialize a DMA transfer, and it just happens in the background asynchronously to what we're doing. Now, there are a whole bunch of caveats to that, right? DMA transfers may block access to some parts of memory for the CPU, so the CPU may have to wait, or the DMA transfer may have to wait for the CPU. There's a bunch of really interesting and complicated conditions about how this works. It is never just as simple as you initialize a transfer and it gets sent, but basically, we can just say we initialize a transfer and it gets sent. So DMA, Direct Memory Access, sending things between hardware components. This is a core part of working with the PlayStation 2. It's a core part of pretty much every serious computer, right? I'm pretty sure that most meaningful communication between hardware components is done by DMA. So like if you're sending info to like the GPU of your PC, DMA, right? It's everywhere. Really awesome and useful concept, and it's really cool working on a system that puts complete control of this memory stuff in your hands. You use the CPU to tell the DMA to get memory from one component to another. Exactly. So again, all of our transfers for now, we're going to be sending from the CPU to other components. There are actually DMA transfers that can read back out of VRAM, can read back out of interesting places, right? There are 3 DMA channels for the SPU. So there's like a to, a from, and then one that does both. It's really complicated stuff. The hardware manuals go into excruciating detail about a whole bunch of weird performance characteristics of this. A lot of it went over my head. This is like such a small amount of what DMA is capable of on a PlayStation 2, but this is all we need to get something running for now. Perfect. Thank you. That was a really good question. Is there an analog of DMA for normal desktop computers? I'm pretty sure it's just DMA, right? Is there like, I don't know. I'm pretty sure DMA is just like what it's called, and it's conceptually the same thing. Don't quote me on that. I don't know much about like a lot of the technical details of modern computer architecture. All the computer architecture stuff I did was like, I don't know. There's like a classic book, Hennessy and what's his name? Book about like RISC architecture design. Really good book. I think it's called, oh man, it completely escapes me. The other book that I recommend for learning about like really basic computer architecture is The Elements of Computer Programming, The Elements of Computer Architecture, which is by Nissim Noam Shokin, I think. It's like the book that the NAND to Tetris course is based on. Really awesome stuff. But it doesn't tell you about DMA and how like a modern computer is actually put together like holistically. Cool. So, send source chain buffer. This is going to be basically the same function that we already use. We're just going to do a different thing at the 11th hour. And we're going to use PS2SDK functions for this DMA stuff. It's probably worth also pulling up the definitions of these functions just to have a look at what they're doing behind the scenes. So, maybe a good one. If we look at the sample for drawing a texture, I know that does have send chain. Sanapsido asks, do you think this SDK works on macOS or is it a Linux distro? It may. Does it? Mac. So, I mean, apparently it runs on macOS. Building it may be a bit iffy because of differences between BSD tools and GNU tools. So if you're working on macOS, I would say definitely go for the Docker image. I did try and build this on FreeBSD or OpenBSD once. I tried to build it on a BSD, and it turns out that BSD make is very, very different to GNU make. So the make files had a bunch of issues. So yeah, I would say Docker's the way to go. Cool. So DMA channel send chain. Let's actually pull up the definition of send chain. Where DMA channel send. Oh no, hold on. So all these functions have this ucab variant as well. We're gonna need to learn about that at some point, but for now we're just gonna leave it. DMA channel send chain. Basically, it's just a different memory region. Okay. Or I guess it's like a memory overlay, but anyway, yeah. Send chain. So we give it a channel, we give it the data, we give it the size of the data. Now I believe this is in quad words, and then flags, I think will always be 0 in our case, and SPR. SPR is something to do with. Okay, I don't know what this argument is actually. I'm pretty sure we can just pass it 0 again. Is this actually? Hold on. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yeah, we just passed 0. Cool. So, what does this function do? PS2SDK implementation of this send chain stuff. So this is a magic memory value for a memory mapped register on the PlayStation 2. There's a bunch of these. The main way of interacting with the DMA hardware is by setting magic memory addresses that are mapped to registers. And this is why I don't want to implement this myself, right? Especially because I'm trying to use Lua interfaces for interacting with hardware, and I think doing this in Lua, I don't know, it just feels kind of gross. So DMA set status, we're telling it which DMA channel to use. Who even knows what this is? This is to do with like synchronization of either multiple transfers or multiple memory things happening. There's a lot of nuance to this that I don't fully understand. Cool. So yeah, so we give it the number. Why does this? Hold on. Set the data size. Why does this set quad word count to 0? Is this the number of? That's interesting. So we use this data size argument here, but when we actually seemingly set the number of quad words we want to transfer, this doesn't seem to. It seems to just hard code it to 0. So DMA send DMA channel send normal. Does normal do the same thing? Yeah, see this actually sets this field. Oh, hold on, because I think this is blank because when we send in chain, we actually don't send any quad words, right? Like the chain doesn't contain, the DMA tag itself doesn't contain any data, but we're telling it that it's a DMA chain, so then it will look at the first DMA tag and determine how many quad words to send based on that. Okay, that makes sense. If that doesn't make sense to you, that's fine. That makes sense to me. That's a very subtle thing. And then yeah, we're just setting a couple of, I think, registers to magic values, and that's going to kick off the DMA. So, as far as we're concerned, all we need to do is say DMA channel send chain. Now what else is interesting actually is I'm not totally sure what our buffer size needs to be. Maybe it is just the size, what our data size is. I guess it's the size of our buffer, right? We're telling Well, it doesn't do much with the size of the buffer. So yeah, this should be fine. This should be fine. It's just the size of the buffer, and then we don't have flags. We don't have whatever this SPR field is. Just some weird argument, maybe telling it to use scratchpad memory. But the point is the important one, and the number of chord words. Okay, cool. That actually wasn't too hard. Send chain buffer, and let's also rename this one to send normal buffer. Cool. So then Lua set field L send chain. Okay, so we've got a send chain function. If we call this now, nothing will happen, but we should be able to compile. That is... Oh, hold on, I need to actually start Docker. I really need to do this on startup. There's no reason not to, but I don't know. I just like the idea of starting up like a minimal set of things. So if I go make docker elf, okay, DMA send source chain buffer. Oh yeah, because I didn't name this function correctly. Send source. It is important that we oh, maybe not. Maybe it isn't important. Send chain buffer. Maybe we don't need to specify source. And that has built. Perfect. Okay. So I should be able to run, and just something will run. I don't know. I think I might have had... Oh, right. I need to update my examples. So... dot send. Oh yeah, awesome. I thought I was gonna have to update this in a bunch of places, but I just need to go to draw 2d.lua. I need to find dma.send, and I change this to send normal. Normal. Or did I call it normal send? What did... Wait. What did I call this? Send normal. Cool. So now if I run... Yeah, cool. I've got it set up to use our stress test, and that's not the best. Let's go back to main.lua require rect, I guess. We'll just do our like basic rectangle drawing test. Oh, which is broken. Do I have a texture test? I don't. Oh no, I do. Hold on. What did that say? Yeah, let's slow down. Let's read our errors. Arithmetic on a nil field. Attempted to perform arithmetic on a nil field base pointer. Okay. Just a quick note, by the way, while this is getting started up. I've added a nicer startup screen. If you pull this engine down and build it, you can like override. These are just kind of defines. Print out the arguments. Print out the startup time for Lua. Print out how long it's taking to load these files. How long it takes to, you know, like do the I/O versus actually p-call the file, like evaluate the file. I think that's pretty cool, right? I think that's actually super useful because my startup times were pretty abysmal on the PlayStation 2. So I simplified this. Alright, I simplified it. Yeah, I kind of simplified the way I was thinking about startup. I cleaned some stuff up from the Dungeon Crawler repo. And yeah, I logged things out so that it's a little bit easier for me to work with. Okay, draw 2D Lua 67. Draw 2D Lua line 67. Arithmetic base pointer. Gotta be responsible and fix your sleep schedule. No worries, Anakim Luke. Have a wonderful night. Thank you for stopping by. Thank you for asking some really good questions. That was awesome. I'm sure, as I said, other people will be thinking the same thing. Alright, so draw sprite. For some reason our base pointer is nil. So let's go back to our texture example. What do we do? Test text, draw 2D, load texture. I think this just comes down to the test texture, right? I must have changed something. So if I look in asset, we have test.tga. If I look in if I look in dist, sorry, we have test.tga. So draw 2D, load texture. VRAM alloc should be returning an address. That should be fine. Really got to clean this logic up, make it a bit more watertight. Because this seems to work, right? Like, okay, so if base pointer's nil, it should fail here, but it doesn't. Why is this already broken? This is bizarre. Hold on. I might have some incompatible changes with something. What did I changed some things in this file, right? So, like, what if I just no, I should have just compared. Hold on. Oh well, what is different here? Texture. Test text, load texture. Weird. Yeah, okay, this should be what is going on? Troubleshooting 64 on start. Oh no, we finished on start. We've started the first frame and we instantly fall over. Okay. Oh, hold on. There was another error first. This would explain it. Attempt to call nil value sent. It's because when we load our texture, 171 was that? Yep. Send normal. So now if I run nil value send 186. Hold on, let's just we got a few of these things hanging out. There we go. That was really silly. Okay. Let's also just, while we're going, update this this log line. I've now got an FPS counter, so we can see when we run this. We're running at about 30 frames a second. That's pretty cool. That's a pretty good thing to have. Okay, so we almost stumbled at the first hurdle, but that's okay. So we've replaced all of our sends with send normals. Now we need to come in and pretty much... Well, we still want to do this for when we upload the image. So load texture. Oh, sorry, there are some very excited dogs on the street. There's a woman who walks past. She has like 5 very small fluffy dogs. It seems like too many small fluffy dogs, and they're very yappy. I don't know if that's picking up on my camera, but like they are not having a good day today. So this happens entirely outside of my normal draw buffer building flow, so this is fine. Where are the other send normals? When we send normal. Apparently typing is also my other biggest hurdle today. So, when we... This is... Wait. Yeah, this is part of load texture. Okay, so 2 of these send normals are in load texture and then the other one is in draw kick. So this is the one we want to send to send chain. So now if I run this, it'll fail. Not only does it fail, it TLB misses, because it tries to interpret the first part of our draw buffer as a DMA tag, which basically means it's probably trying to look at an invalid part of memory and doing something weird. So that's going to crash us. That is going to crash us pretty hard. Okay. Okay. So we need to add the actual DMA tag when we start drawing. So we have a function frame start, or new buffer actually. The first thing we need to put in a new buffer is the start of a DMA tag. Oof. And so this loop count, where we count what's inside of it, we're going to have to update part of the DMA tag with this info as well. So this is going to be more complicated than I thought. Let's quickly investigate how this texture example builds it. So if I go, is this? Yeah, perfect. This uses their bloody packet API. I think this is kind of very, very, very hard to read. So if I jump to the definition of packet init, there's a packet data, packet, blah, 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 blah. Q, draw texture transfer. No, we don't want this. We want render. What's the first thing you put in your packet? Packet init, packet normal. When do you start filling actual draw commands? Current. Wait, let's put something in current. Where do you get used? Where does it get used? Current.data. Okay. Draw disable test. But there should be something before this, right? Because this is going to get sent. Or does this just send normal the actual like draw buffer? Yeah, just sent. Oh, that's very annoying. Okay, so there is a constant DMA tag. There is something defined here for actually like setting up a DMA tag. Because I guess the only thing I'm missing here is that a DMA tag, a DMA tag is 64 bits, right? So it looks like this. These fields are used for different things depending on the type or the ID. Okay, so quad word count is always used. That's a number of quad words that are in this DMA packet, I think they're called, right? DMA tags define a DMA packet. Sure, let's go with that. Address is ignored for our continuation packets. So when there's just a bunch of stuff that's all adjacent in memory, address, we don't care about it. It's probably ignored, but we'll set it to 0 just to be safe. If our ID is set to something like ref, then every DMA tag, the address field is going to be where in memory we're referencing, and similarly with next, the address field is going to be where we jump to next. And also just quickly to throw in the bits here. So this is bit 0 to bit 15. This is bit 24 to bit 32. And then this is the upper word, right? But there's something else. So this is like half of a quad word, right? What comes after this? What does that look like? There's got to be something after. I don't know what we put here. Or do we not? Do we just put... That just doesn't feel right to me. That just doesn't feel right to me. Oh, hold on. It's actually right there in the documentation. The tag is 128 bits in length, and the lower 64 bits are effective. I love the wording of the PlayStation 2 hardware manuals. They're very odd at times because they're translated from Japanese, and so some of the expressions used are just not how someone with English as their first language would write it. transferring data, 16 quad words, blah, blah, blah. The tag is 128 bits, 16 bytes in length, and the lower 64 bits are effective. These are 64 very effective bits. The format is as follows, blah, blah, blah. Okay, that's actually very easy to construct. So we need the number of quad words. So let's make a function for this. Function draw new tag. New CNT. So self.buff. I'm just going to take some quick examples, quickly refresh myself on what my, yes, push int, that's right, push int. So the lower 16 bits, the lower 2 bytes of this, it's the number of quad words. So we'll just say QW for now. That's the entire, no, it isn't the entire int, because we have the top, what's this? The top 8? Yeah, the top byte is this ID/flag field. So it's this plus 2 times, plus 2 to the 24. So I think Lua just has like a sane to the power of operator times DMA.cnt. We'll define this as a constant in our DMA object. So we push that integer, and then self.buff.push int. We push another integer, which is 0 because we don't have an address. And then we push 2 more, just 2 more 0 ints, right? Because the upper 64 bits of the quad word is ignored. If we're doing transfers, sorry, just another like weird side tangent, but if we're sending arbitrary data off to a vector unit for manipulation, you can absolutely use these two upper words for just arbitrary crap that the vector unit can pull out and work with. Because, you know, if you're really like trying to jam stuff together into an efficient space, you know, you want to make use of every word. You want to make use of as much as you can. But yeah, for our purpose, these are just going to be zeros. So there's a few things missing here. The first thing first is that we need to know what this quad word count is. And when we actually create the continuation, we don't know what the quad word count is. So what we're going to do is we're going to store this first position. So we need like, let's go local, the quad word count, it's going to be self.buff tell, or I have a function for this, I can't remember what it is. So we're going to jump over to buffer Lua, and it's called size head. We get the head. That's actually that easy. So if I go back over to, do I have it in here? Buff.head. When I kick, I do something, right? Yeah, update last tag loops. See, when we don't actually know how much we're putting into these buffers until we until we're done with them, right? So when we make a new GIF tag, we update the last tag's loops, like the number of loops. But when we so the only time I don't need to do this, I don't need to update, I don't need a new DMA tag every time we call this, right? This is because our draws get split up into smaller things, and different GIF transfers have different formats, and different GIF tags have different formats. But as far as the DMA transfer is concerned, everything is just a stream of bytes. So the only time we need to update the number of quad words in our DMA chain is when we kick. So we need another piece of state, and that's going to be called DMATag quad words. Okay, so when we end the frame, we call frame end, and then we say self.buff. Can we just like, what do we do? How do I do it? Hold on, how do I do it? update last tag loops. How does this function work? Buff read, buff write. Okay, I can just give it an arbitrary place. Tag loop pointer. Oh wow, yeah. So I just give it an arbitrary address. Perfect. So kick. We say, okay, here we go. Self.buff write self.DMATag quad word pointer, and we write self.DMATag quad word count. We need another piece of state. DMATag quad word pointer. Right? This is messy, but it works. It works. Frame end. What am I doing in frame end here? Self.kick. Okay, perfect. Quad word pointer, DMA tag, quad word count. We'll use quad word count. We use the same word. So then when we CNT, when we make this, we set self.DMATag quad word pointer. So this puts a new DMA tag into our buffer. It saves. So let me draw a picture of this, because this is this, right? We have our buffer, we're creating it in memory. And when we create our buffer in memory, we need to store this address, right? We remember this because once we've written all of this, once we've written all of this stuff down here for the first tag, we need to then write into this tag how many things we wrote. So we need to remember where this is in our buffer, okay? We need to remember where this is in our buffer. And also, this flag, let's do the bit manipulation on the C side because it's a constant anyway, and we can just add them together with things. That'll be fine. Or, you know, basically logically ORing them together with things. Awesome. So let's go define this as a constant. If we go back over to, if this thing would bloody work for me, if it would not steal my focus over to this window for some reason. If we go back to DMA Lua, Lua push integer L DMA, what was this called again? DMATag CNT? Yeah. DMATag. So these are all the different tag types, right? They're defined twice for some reason, but CNT is going to be 0x01. Let's just say 1 times, what's 2 to the power of 24 as a magic number? Oh, well, no, let's left shift it. That's even nicer, right? Lua set field L -2, and this is going to be called CNT. It's better to do this bit manipulation on the C side, and then in our C APIs, we will use the PS2SDK constant and manipulate it kind of, you know, when we're building these things rather than up front. But yeah, for the sake of Lua, I think this is a lot nicer. And while we're here, let's actually do the other constants as well. Push integer L, the other ones we care about anyway. So we need end. That's going to be 7, right shift 24, left shift 24 rather. And we need ref, ref E. Let's do next as well, I guess. Okay, so CNT and ref E and next. And these are going to be, where are we going? Ref is going to be 3. Ref E is probably going to be like 4, I would guess. Or 0, okay. well, I mean, yeah, this is just 0, no shift needed. And then next is going to be something more exotic, 2. All right. Magic constants defined. This should still build. Yep, everything looks good. Okay, so we can build a new CNT tag. And then when we kick, it's going to update the CNT tag. So when we say new buffer, we just have to say self new CNT. Okay. So now if I run this, it'll probably break again, but it'll break in more exciting and interesting ways. Okay, so we didn't hit any errors, which is good. So what we need to do is go into our DMA Lua. We need to re-enable our debug printing, because otherwise we're just never going to know. And we're just going to turn this on for our chain send, which is nice. Because it means we're not going to get stuff spammed out except for what we absolutely need to see, right? So the image loading, done over normal mode, we don't need to see it. This chain, we need to see. So straight away, the first thing that's being written into this buffer is garbage. We're putting something here, right? This continuation should have type 1. So if we look at our format for the DMA tag, right? Quad word count should not be 0. ID flag, we expect this to be 1. Okay, so we want 1 here. We want like, I could count these lines if I really wanted, but like this is 1 quad word. This is 2 quad words. 1, 2, 3, 1 byte, 2 bytes, 3 bytes, 4 bytes. This is 1 quad word. So the number of lines is the number of quad words. Essentially not 0. So we've messed up. We've messed up in a big way. I need to run to the bathroom. When I come back, we will crack the mystery of this buffer and why this is all zeros. The answer, the spoiler, is that I've done something very, very silly wrong in my Lua code, but we'll work it out. Back in a second. Alright, I'm back. I realized I forgot to take my my meds this morning, so I had to quickly do that, and I also found my glasses, which should help. Okay. Why is this wrong? Let's go back to draw2d.lua. At frame starts, we call new buffer. In new buffer, we set our state to none. Yep, this is all good normal setup stuff. We start a new continuation. We start a new gift tag, so new CNT. So first off, right, there should be no world in which this is 0, right? If I go back to DMA Lua.c, did I not rebuild? I rebuilt, right? So this should never be all zeros. Never. The very first thing we push in should be a magic number. If this can please focus to right. DMA Lua.c. So unless this is getting casted somehow and this 1 is getting dropped, but I really struggle to see where that would happen. Push an integer, set the field CNT. Let's print DMA CNT equals. Let's do something dumb for now. Let's do some debug printing. I don't really know what else I can be doing here. This is a non-zero number, right? This is 2 to the 24. This is what we expect it to be. So why? Where is it? Where did it go? Oh! I'm very silly. Hold on. Hold on. So when we kick. Okay. We don't want to just override this. We need to go local. We need to add this on. We don't want to just completely obliterate what we already had. So let's go local. Let's call it the low word equals self.buff read self.DMATag quad word pointer. And we are gonna set this value to LW plus this. Okay, so now if I run, we should see something non-zero here. And we get a miss. That's not good. Nil value, DMATag QWC. Arithmetic on nil value. DMATag QWC. I think I called it QWS, right? There we go. And we can see in the lower word 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, I think that's right. I think that lines up, right? The 25th bit, I guess, if this is 1. So if we count from 0, the 24th bit, that is what is being set here. So this is correct. This is the correct ID. Awesome. Our quad word count, of course, is 0 because we've got this self.DMATag quad words. This is never being set. Okay, so every time we write something into this buffer, we need to update this, or we need to look at the total size of the buffer. Can we just calculate this at the end? Okay, so first off, does this quad word count include the DMA tag? That is a question that only the system hardware manuals can answer. So I'm gonna have to pull them up. Okay, Sony, please no sue. I don't know if it's better or worse saying that. I don't know if that puts me in more or less risk. So, source chain mode can perform DMA transfers from memory to a peripheral and specifies the address and data size with the tag. Specifies the address and data size with the tag in the transfer packet. Okay, so it includes the DMA tag. So it's just the buffer. So actually, I don't even need to store. This is always going to be, the way I've set this up, this value is always going to be 0, right? Because we've just made a new buffer. The only time this gets called. Okay, let's keep this little bit of logic. It's a little bit cumbersome, but it might save us in the future if we end up putting multiple DMA tags in one buffer, which we are going to do pretty soon. Okay, we'll keep this. But for now, let's just say the number of quad words is the entire size of the buffer. Okay. Function draw kick. We'll just forget u, and let's say local qwc equals self.buff head divided by 16 math.floor if self.buff.head mod 16 is not 0, then qwc, we have to add 1 onto it. You have to round up the number of quad words. SBPO2, yo. Hello, welcome. You have stopped by at what is hopefully a very exciting time where something is about to work. We are bouncing bits and bytes around between hardware components of the PlayStation 2. Okay, and we're using Lua to build the buffers because it's a little bit faster to prototype, even though this is a really, really slow and kind of crappy interface. You love to see it? Awesome. It's awesome when people come by and are excited about the PlayStation 2. I started streaming this, I was like, are people going to be interested in this? I don't know, but you find out, right? You find out. So, we're going to add on the quad word count. And we're going to see what this looks like when we run it. It's still not going to actually do anything yet, right? We're still not quite at the point of doing anything, but 3C, this is a promising number. This is a promising number. So if I copy this, let's just pull up like a scratch buffer, I guess. Okay, that didn't actually copy to my clipboard for some reason. We can... We'll just like grab the output of this into a buffer, right? Perfect. So now I clean this up. This is one of my favorite Vim commands that I've learned about fairly recently, by the way. Everyone should learn about R. So this has 60 lines and 60 in hex. Is it 1C? It's 3C. DMA. Memo Workshop, welcome. DMA, yeah, it's a very exciting thing. TLB misses in the log is kind of spooky. Yeah, no. So, PCSX2 is super flexible about TLB misses for some reason. I'm guessing this is just DMA tag shenanigans, especially because I don't actually have an end tag, so when it hits the end here, it is just gonna like run off into garbage memory potentially. I don't know what is happening. If I still see those TLB misses once I put an end tag on, I'm gonna take it more seriously. Cool. So I said that was 3C, right? So yeah, so we've got the correct number of quad words, and we've got the correct type of DMA transfer. That is good. That is good news. So now, yeah, the thing I need to put on the end, right? It's this end tag. So let's say, let's do it here, I guess. Let's go draw DMA end. DMA end. I need to be more consistent with this naming. I should probably call this DMA CNT or something, or start DMA CNT and probably start DMA end, or maybe just DMA end, because this doesn't actually have like a, but this doesn't like start anything. It is just the end. So we say self.buff push int DMA.end, and then we push 3 zeros. It's kind of bad that this is an interesting comment. It's kind of bad that it ignores the TLB misses, in your opinion, because they're fatal on hardware. Yeah, I kind of agree. I've had situations where I've had things just quietly, you know, accept failures on PCSX2 and then explode on hardware. What I would like to see is probably an option for like a strict mode, if that was possible in PCSX2. So one that, you know, if you hit a TLB miss, it explodes. Specifically, I guess, for homebrew developers and maybe modders who are concerned about hardware compatibility. You know, something that actually told you, hey, this went wrong at this moment, and here is the stack trace. You know, here's the stack for this. Here's like the, you can see what's happening. It opens the debugger or something. The PCSX2 debugger is really cool. It's a really powerful tool. I've gotten a lot of use out of it, and something like this would help a lot. The other kind of related thing, I guess, there are some cases where bad memory dereferences can actually crash PCSX2. So if I dereference a null pointer in my PlayStation 2 program, it doesn't just like, the emulator doesn't just break, it fully crashes. So it would be good, again, to somehow catch that and present it maybe in the debugger. And again, maybe some kind of strict mode, even if it was like a compiler flag, and maybe that compiler flag already exists, I would love to hear about it. But that would be a really useful development feature for people doing homebrew and other stuff. So yeah, that's a really good point, and I agree. I think, yeah, they've aimed for compatibility, and you know, if they just want games to work, it's a really useful thing. PCSX2 is the main PS2 emulator, so when I hit leader R, this opens up my homebrew in PCSX2. We get some PCSX2 devs stop by in my chat sometimes, which is really cool. Mimicring, thanks me for posting the VODs to YouTube. You are absolutely welcome. Yeah, I'm really surprised at how many people have been finding my YouTube videos. And actually, just before I test this DMA end out a bit more properly, I want to jump over, okay? So my thumbnail design 1.0, fairly bare bones, fairly clean. People seem to be clicking on them. I had I think about an 8% impression click-through rate on this video, which compared to my other channel is like a lot better. But I'm trying this new. Like, I think this is a fairly good clickbait thumbnail. What does everyone think of my thumbnail skills, right? I'm kind of thinking of committing to this format rather than I don't know, this one was like a bit too noisy, a bit too busy. I like the colored outline on the PS2, but I don't know if this is like too clickbait. What are people vibing? What do people feel? I would love some feedback on this stuff. And yeah, if anyone has like thoughts on branding overall, would be cool. Cool, so DMA end. You love the clickbait. Oh, I live for a good bit of clickbait. Okay, we capitalized something where we shouldn't have. That means that we crash. Yeah. I think that was probably just like a vim mash as well, right? This is an end tag. This is a start tag. We still have a TLB miss. The TLB miss actually seems to come when we're loading a texture, which is a bit weird. Oh, hold on. Do we call new buffer? Do we call new buffer and load texture? If we call new buffer and load texture, we've just broken texture loading. I don't think we do though. We only call new buffer in draw kick and in frame start. Okay, well that's fine. Okay, so that seemed promising, but it is not promising. Maybe we need to try a simpler example first, actually. Let's go to min. So min is my minimum possible example, right? It does basically nothing. That's actually too minimal. What else have we got? We've got... The rectangle example is broken for some reason. I don't know why. Let's try the stress test. That might actually be a little bit simpler, even though it's a lot. So if I go into main... Unfortunately, I can't just like pass an argument to this program. Okay. So this doesn't crash. Or maybe it does. Maybe it does actually hit that TLB and I'm just losing it in the logs. No TLB miss, which is good. This looks like the correct number of quad words for this massive buffer. I'll take your word for it. Okay, so what if I come into our stress test and I just draw like way fewer triangles? Frame. How am I setting this up? DD. So let's say like 2 triangles in each direction, something a bit more sensible. We draw one and then we hang forever. No TLB miss, but something has gone wrong. One of our draw might just be hanging forever in terms of, our draw might be hanging forever in terms of the DMA never completing properly. I might have one too many quad words. So hold on, let's go back to our friend the system hardware manual. Okay. Source chain mode can perform. Source chain mode can perform. DMA transfer from memory to specifies the address and data size with the DMA. Oh, I know what I've done. I have indeed one too many quad words here, right? So the way this works, again, I've been drawing some pictures, right? The way continuations work, you have your DMA tag, you have your data, then you have the next DMA tag, okay? This end, this is actually, this end that we have here, this is another DMA tag, right? This is a DMA tag that says this is the end of DMA. Why is it its own tag? Complicated reasons. But we can't include this tag in our total number of quad words. So either we calculate this draw kick. Either we put this after we've calculated here, which I think is okay. Let's try again. Let's try this again. 4B. So yeah, so we have one fewer quad word now. That's correct. However, our draw never completes. Again, either our DMA transfer never completes or we're not sending the right stuff, so our draw never completes. I think this is, like, again, this looks like the right kind of number. Let's maybe just like jump into a scratch buffer here. So if I line 76 lines and 76 in hex should be 2B, right? 4C. 4C. I'm saying 4B. So maybe I am one short. 76. 1, 2, 3, 76. Wait, but does that mean there are only 75 lines? Which is 4B. Refraction PCSX2, hey! We were just talking about PCSX2 stuff. Well, welcome to the stream. I'm just trying to get DMA source chain transfers set up. Yeah, the word is spreading. So, yeah, my draw seems to never be completing, or something. I do one frame and then I hang forever. So, you know, I guess like here's my draw and I'm just sandwiching DMA tags around it. So I've got my my continuation tag, quad word count, continuation, no address, and then just like your padding, double word, and then an end tag at the end. And that should work, right? So I don't actually know what's hanging here. I guess maybe the debugger might help. I guess it's a little bit harder because I'm in Lua world as well. Also, I think this just crashed. Yeah, that just crashed PCSX2. Let's have a look. Let's see if we can just like... Okay, well I don't have any... Oh yeah, there we go. There we go. Nope. Don't get any symbols. That's fine. Ooh, when the TTE bit's set. Now here's something I haven't thought about. This is another detail which I think is somewhere in the hardware manuals, right? Is there, but just quickly, is there a problem with me showing these hardware manuals if PCSX2 devs are watching? Is there like concerns about the integrity of PCSX2 if you guys have seen hardware manuals? Yeah. Look, if I get a slap on the wrist for this, I will be upset. But it's just super interesting stuff, right? Like look at this table. This table is beautiful. It's so cool seeing the way the there's so much depth to the memory transfers. But there's a bit of talk about TTE. Where is it? Yeah, translate with tag, right? That's TTE. So that's set with a memory mapped register, right? So where does that get set? It's set on CHCR. So I had send DMA send chain. Cool. So this is the PS2SDK function that I'm calling. So I've been having a look at the definition of this to make sure. So DMA, the CHCR register. Okay, what do these mean? So DMA set CHCR. Direction mode. So the fourth argument, 1, 2, 3 flags and transfer tag. Okay, so I actually need to wait, TTE. But which value of TTA is on? I have it enabled. So wait. Wait, so is 0 or 1 enabled? Like, so this is 1 and this is 0? There'll be a constant defined in PS2SDK somewhere. TTE. Yeah, it needs to be set in flags. So yeah, I know there's a constant for it, but like which one is on and which one? I guess I can just like toggle it, right? Whether to transfer the tag itself with the data or not can be specified by the TTE flag. Yeah, the tag itself is transferred before. Yeah, but which value do I set? Which value do I set? Specify the TTE flag. Okay, so I think I just have to look at the definition of the register memory map, right? So if I like, what page is this? This is page 45. This is a good page. Okay, here we go, page 74. 0 does not transfer the DMA tag. So that's what I have, so that's fine. Okay, so do not transfer DMA tag, 0. Yeah. Wait, why do I want to send the DMA tag? I'm sending to GIF, right? So don't I just want the draw commands to go through? This is interesting stuff. I'm going to pull this up on stream. I need to get a better like chat interface than just pulling a browser window open. You need to reserve 128 bits worth for the DMA tag itself. Do you mean factor it into the quad word count? The way I'm building this, new CNT. The way I'm building this is to just push four words, and again, this is a disgusting interface to build buffers, but I think it's actually pretty like readable and simple and easy to fiddle around with quickly. I hope to get hot reloading working at some point, but that also sounds dangerous. The lower 32 bits of the is the transfer type in the quad word count. The upper is the memory address. Then the upper 64 bits need to be blank. That is what I've got. So so when I push this through, right, the first thing I do is just set the type. The quad word count is set retrospectively at the end, and then I send 0 address and then just some padding bits. Oh, padding. I guess it is like that is the DMA tag. The wording of this in the hardware manual, by the way, is hilarious. If I go back to page 45, where is it? The tag is 128 bits in length, and the lower 64 bits are effective. Right, I love that wording so much. Effective, right? Not active, not the upper 64 bits are basically ignored. Effective. Apparently this is a lot better than what they got in the early days of the PS2 as well, right? Apparently the early hardware manuals were like shockingly translated. And so you're just like, hey, here's a lump of really exotic hardware. Good luck. It'd be great to go back in time, like 15 years, and pick Andy Gavin's brain about PS2 hardware quirks. Okay, so let's say my my packet. So what I'm sending is this, right? So you've got this thing that confused us in our last conversation, where the PS2SDK screen clear, and then my normal GIF stuff to just draw a couple of triangles. So hold on, can I zoom in here? This is as huge as it goes, apparently. But yeah, so this is what gets built, right? Lower double word, upper double word. You can read it. Cool. Sorry. I'll calm down. So the last byte. So this looks good, right? We've got the upper word 1, 2, 3, 4, 5, 6, 7, 8. Yep. And then that looks good. The GIF tags should be fine. I ran this like before I added the DMA stuff, and the GIF tags were working. And then the end should just be this, right? You should just have like just this magic 7 for the end tag. Output to STD out, yeah, it's harder to like scroll around in it, I find. I don't know. My favorite, which I did before, was the :R command in Vim. So you like dump it to a buffer and then poke around with it. I think that's a fun way to play around with logs. Maybe I should make a test that fits into like one window. Actually, hold on. Let me dump this, right? So let's go. It looks okay. Yeah, I feel like this is good, right? So what could be happening is... Actually, hold on. Before I dump this, let's have a quick look at main.c. Because... So I call my onFrame, draw wait sync, graph wait sync. I never DMA wait. So could it be... Oh, well, no, I call DMA wait fast here. Could it... I don't know. I don't know what... Like, I feel like this order of waits should be fine, right? Like, after we draw, we wait for the draw to finish. So this implicitly should mean that the DMA transfer has finished, because we're sending, like, a GS finish. We're setting GS finish. Then we wait for vsync. We do our stuff, blah, blah, blah. I put this here just to be safe, just to make sure there was nothing, like, pending before we start the next frame. But because of how this works... I guess if we build our packets cleverly, we could do things, in the time between draw and the next frame starting, right? If we want to like, yeah, hopefully it stops on the GIF stat. When the DMA finishes, it'll still have 16 quad words in the buffer. So the quad words from the GIF stat. 16 quad words in the buffer. Does that include like... Because yeah, the DMA feeds into the FIFO. DMA ends once it's fed into that. Yeah, okay. So it will still be doing things once the DMA has ended. That makes sense. Okay. Yeah, so in conclusion, it looks good. Right? That's a path set to 3. The DMA data looks fine. So let me just quickly like fly over to texture.lua as well. Well, first off, we can get rid of this. We're no longer generating textures in memory. So, frame start, set color, draw a sprite, frame end. I'm really not doing much in these frames. Yeah, for the console, I really like. Part one of this is get it working here, and then part two of this is actually verify that this works on console. When I point down here, my PlayStation 2 and TV is just like on the ground here. Man, I need to get a better PS2 setup. I'm gonna at some point buy a fat PlayStation 2, get a hard drive in it. It's gonna be great, but yeah, it's all a work in progress. Man, I ordered some new speakers the other day, actually. I'm really excited. Our TV has just like terrible built-in speakers. I was gonna get a soundbar, but then I decided soundbars sucked. And so, yeah, I've just bought some nice, just some active speakers. I don't have an amp or anything, but it's gonna be life-changing. We're gonna actually hear dialogue over music. Also, I opened the wrong file there, but this is like very, very similar. It just has like a layer of interaction, right? This draw just puts a triangle to the screen. The texture example had a really interesting quirk where it was triggering a TLB miss, which the emulator's fine with, but like I don't know where this is coming from. When I try and load my texture, TLB miss. Nothing I've changed should be impacting this, so it's really odd. And then Lua crashes because it never actually sets FPS and blah blah blah. I can probably actually fix that quickly as well. Yeah, cool. Make sure my file load is blocking. That is a good point. So tga.c, it's pretty... I don't know much about how PS2 file IO works, right? What I'm using is just built on PS2SDK stuff, and so that's like a whole rabbit hole, right? If I like... I don't think... Give this... Yeah, I'm actually not sure how that stuff's implemented. Maybe I can use one of their different one of their different IOP interfaces. I'm not totally sure. I'm actually not sure on that one. fopen has worked for me so far on hardware as well, so I've been happy with it. But this should be blocking. And not only should this be blocking, but it should be before any DMA anything kicks off, right? Like this all happens up front because at the moment my my draw interface all uses one buffer, so I just don't support texture loading mid-frame or anything yet. That's going to get a lot easier once I support DMA tags, and especially like refs. Because again, at the moment when I load a texture into VRAM, I copy it from memory into a buffer which then gets uploaded, which is stupid. Hideously inefficient, but the only way to do it if you don't have DMA chains and refs implemented. Okay. Well, let's go in here. Let's see if we can see where this falls over, right? Where in my main loop does this actually flip out? Wait, draw. Okay, so the draw never completes. That's good, right? We can do it. Well, hold on. I can't work with this example because of these TLB misses. That's gonna complicate things more. So if we go back to main, swap over to, go back to our stress test. Yeah. Oh, a flush. Now that's interesting, right? Okay, so is there a PS2SDK version of this? DMA flush? Nah. But yeah, that's a really good point, right? Maybe something not getting flushed. You have to flush the cache. So let's go to my DMA implementation and just say that I'm always gonna flush the cache. Which I don't know how to do. So, cause yeah, this just kicks it off, right? So maybe if I wait fast, right, will that... Let's see if it does it. It doesn't. Dodgy CSDK, it's flush case. Flush cache. Oh yeah, flush cache. Let's try it. Hold on, I need to rebuild. Implicit declaration. Where do you come from, flush cache? Kernel.h, cool. That checks out. What am I doing? For B. Could I be one quad word short here? Let me just see if I'm one quad word short. I was a little bit suspicious of that, honestly. Draw kick. What is a TLB miss? So a TLB miss, translation look aside buffer, right? Translation something buffer. It's to do with the way a memory address is like resolved into physical memory, right? I don't know. Yeah. Minus the tag. Should have 65 quad words in my packet minus the tag. 67 total, I guess. Okay, hold on. Just before I get back to the TLB miss, the quad word count includes the tag, right? I think that's what the hardware manual says. So, hold on, where is it? The packet is transferred. Where was it? Something said it, and I was like, oh, it doesn't include it. Okay, well, yeah, that's probably the problem then. TLB misses happen because of null pointer dereferences. Yeah. In this context, it basically just means we're reading an address that does not actually correspond to valid memory, right? Yeah, translation look-aside buffer is basically for taking a virtual address and converting them to a physical address. Thank you very much, Refraction. That was I remember the semester where I did the course where we learned about that. Really awesome. I actually referenced the textbook. I cannot remember what it's called. But it's... What's his name? Hennessy? It's a textbook. This guy and the other guy that are behind like RISC instruction sets, right? Specifically like MIPS and RISC-V. There's a really great textbook that talks about CPU architecture design, and like gets super nerdy into details of stuff like TLBs and how you actually could build a full RISC-V CPU. Really awesome textbook, highly recommend it. I've forgotten a lot of it apparently. Okay, so the easiest thing to do here, I'm just going to see what happens if I subtract 1. And that doesn't work. Okay, so I'll do what I was saying about before. We'll just grab this buffer here. Okay. So here's our buffer. Yeah, so 76 lines, okay? So this line is part of our... Oops, this line's a DMA tag. This line's a DMA tag. So we have 74 lines in the middle, right? So 74 in hex. I should have 73. Yeah, cool. So it should be 49. And I have 4A. Alright, let's see. I'm gonna do the dumb thing. I'm gonna subtract 2. We're gonna run it. We're gonna see. And that still isn't quite there. Again, the drawer is never submitting. Okay, but that's good to know at least. And again, like this is right. I could turn on GIF logging. PGIF console? No, that's the PS1 GIF. How do I log setting? Yeah, I don't know. I need to have a debug build. Yeah, I really need to start building PCSX2 myself. Sorry, I thought my phone just went off. No, I really should have that. I didn't know there was like better GIF logging tools available. I actually, look, I've been streaming for a little bit. I think I've hit a roadblock. Gitblock, GitHub. You can take a quick look. Now look, I'm going to call it there for now. I might be back on later today, I'm not sure. But I'll grab PCSX2 down on my machine. I'll experiment with building it. 64-bit builds, what's your opinion? Should I play around with them, or will I need to install 32-bit versions of all the libraries? 64-bit works for Linux? Perfect. So that should be fine. That would be really good, actually. Yeah, I'll get that working. 64-bit works well enough. Beautiful. Yeah, if I can use... I have played around with it before. Back in, I think, early 2020, when I was still on Windows, I had like a debug build running in Visual Studio, and I used some like breakpoints to look at what was actually happening in the GS state, which was super interesting. But yeah, I think that would be a really cool tool for exploring how PS2 games out in the wild work as well. Is it possible to use the PS2 packer module without the complete SDK? I believe so. I think it's just a standalone binary. If you build it, it should just work wherever. But yeah, before I go, any other questions, any other thoughts? Otherwise, I will call it there. If you want to have a look at how this stuff is tracking, I've now set up a project in this repo called PS2 Homebrew. You can see what I'm working on. I'll try and keep this up to date. And again, there may be some things that I work on here, that aren't on stream. It'll all be tracked here, which will be cool. The trace logs will at least show you what the DMA is doing and see if that's behaving correctly exactly. Yeah, I didn't realize those tools were there. I thought I had all the logging I could get. So if there are more resources here, that's going to save me a lot of time in the future. That's really good to know. Awesome. All right, thank you. I had some really cool people come and hang out. I need to do more morning streams. I keep waking up on the weekend and thinking, you know what, I feel like doing some PS2 dev. I'm going to jump on a stream, 9 a.m. And then it's like 1:45 before I know it, and I've kind of missed the golden window to actually get people come and watch. Yeah, see, like my day is just starting. It's just hit midday. I'm going to like go for a walk, maybe grab some lunch out somewhere. It is a not miserable Melbourne day, which is a lot to say. 1 a.m. there, man. Yeah. So many of my viewers are like American or Brazilian, I was saying before. But I'm rambling on. Thank you very much for tuning in. Thank you to anyone who's watched this far on YouTube. I see there are a few of you out there. And I will catch you all next time. Thanks for coming. Bye.